In this video lecture, I will handle PLL application. With regard to the feature of PLL, it is applied in communication system because they provide precise timing synchronization. PLLs are foundational in modern telecommunications, computing, and electronic system. The key applications of PLL include AM detection, frequency modulation, and frequency synthesis. Before going to the application, first we recollect the operation of PLL. It is an electronic feedback circuit that recognizes the output phase and frequency with the reference signal. Hence, it is widely used in communication and digital systems. The four blocks of the PLL are phase detector, filter, and VCO, which is nothing but voltage control oscillator. PLLs are widely used in communication systems, FM demodulation, and clock generation. Now we will discuss the application frequency synthesis. It generates a wide range of highly stable, precise frequencies from a single low frequency reference crystal. It is used extensively as local oscillators in radios, cellular phones, and test equipment. It is used in RF transmitters and receivers. The high output frequency from VCO, it is passed through the programmable divider and it is scaled down by a factor of n. Hence, it generates the multiple frequencies from the divide by n network, which is given to the phase detector. So, two frequencies are given to the phase detector and it is passed to the low pass filter and error amplifier as the output of the VCO is taken as the frequency generation, which is given as n by m into f oscillator. Hence, varied number of multiple frequencies are generated. Thus, it is applied as frequency synthesizer. A slight modification in the PLL block will lead to the application of frequency synthesis. The next application is FM demodulation, which is frequency modulation detector. Here, the principle used is the PLL tracks frequency variation and converts the frequency changes to voltage. It provides accurate FM detection. It is used for frequency demodulation by forcing its internal voltage controlled oscillator to track the instantaneous frequency of the incoming signal, which is FM signal. The filtered error voltage required to keep the VCO locked to the input serves as the demodulated baseband output. So, the standard PLL FM demodulator extracts the original message signal through a straightforward closed loop process. So, it as given in the diagram, the signal input is the incoming FM signal which carries the message. Then the tracking is done using the VCO. Then the filter is done using low pass filter. The filtered error voltage acts as the control signal that dynamically adjusts the VCO frequency to match the input FM signal. Because the VCO tracks the changing frequency of the input, the variations in the VCO control voltage represents the true replica of the original modulating message input and thus it acts as the FM detector. The next application is AM demodulation. Here it detects the amplitude modulated wave and thus it gives the input message signal. Here the PLL locks to the carrier frequency and phase of the incoming AM signal. At lock condition, PLL's VCO generates an exact unmodulated copy of the original carrier frequency. The PLL is used for synchronous amplitude modulation, demodulation, by locking the local voltage control oscillator to the exact carrier frequency and phase of the incoming AM signal. This method provides exceptional selectivity and noise immunity compared to conventional envelope detectors. Here, the PLL AM demodulator relies on synchronous detection and involves three main stages. So in the block diagram, it is given the PLL, and PLL, from the PLL, the VCO output is given to the multiplier, which is the phase detector, then low pass filter, and the output of the multiplier is shifted by 90° and it's given to the multiplier. So here the phase locking PLL locks the carrier frequency of the incoming AM signal. The VCO output, which matches the carrier frequency, is shifted by 90°, so it aligns perfectly with the input signal carrier. The incoming AM signal and shifted VCO output are fed to a multiplier, which is the mixer. Then the multiplier output high frequency components and low frequency difference components. So the filter removes the high frequency, leaving only the demodulated message output, which is taken from the low pass filter. Thus, the PLL acts as AM demodulator. In all the applications, the VC plays a major role in generating the output in frequency synthesizer and other detection blocks. So in this slide, we will see the VCO IC operation. It is an electronic component that generates an output signal such as square wave, triangular wave, or sine wave, whose frequency is directly proportional to the input DC control voltage. Thus, the output frequency changes according to input control voltage. It is used in PLL systems, modulation, and signal generators. The IC is a 8-pin IC in which the individual pins represent each function as shown in the diagram. Modulation input is given in 1 pin, 5th pin, and output is taken from either 3rd or 4th pin. Then the external timing components are connected to 6th and 7th pin, which are resistor and capacitor. The input DC voltage dictates the rate at which an internal capacitor charges and discharges for controlling the output frequency. Raising the control voltage increases the frequency, while lowering it decreases the frequency. They generally come in two types: relaxation oscillator and harmonization mode. It generates square wave or triangular wave. In harmonic mode, it will be for sinusoidal RF signals. So main general IC used is NE566, which is popular general purpose 8-pin IC capable of generating both triangular and square wave. It is highly utilized in function generators and generation. The internal block diagram of VCO consists of 4 core building blocks, which is given in the block diagram. It consists of 2 constant current sources for charging and discharging, and a schematic trigger and 2 amplifiers. It operates by linearly charging and discharging the external capacitor, which is connected to simultaneously output the square and triangular wave. Thus, the VCO is controlled by input voltage, and the output frequency F0 is given as 2 into VCC minus VC by R1 C1 into VCC, where F0 is the frequency of oscillation and R1 C1 are the timing component and VC is the control voltage. Thus, the PLL applies in various communication systems, and its principle of operation has been discussed in this lecture. Thank you.